Hello everyone, myself as TB Vangelan. I'm working as Assistant Professor in Mark Twain College of Engineering and Technology. So in this video we are going to see about Playfair cipher, which is one of very simple and best known substitution technique in cryptography and network security. So regarding the contents of the video, here we are going to see what is the technique behind Playfair cipher, and we are going to see how we are going to construct the Playfair matrix, and then we'll see how we can encrypt the given plain text. We'll see a small example. Regarding the Playfair cipher, among various substitution techniques in cryptography, this is a very well-known and very known multiple letter encryption. Here we'll take our input plain text. Here we'll be treating the input plain text as digrams. So we can see this example. So here the input plain text is play. So digrams means we are dividing it as die, that is pair of two. So it will be divided as PL and AY. So now the first step is we have treated the input plain text as digrams, and the next step we have to go for constructing a Playfair matrix, and here is the size of the matrix. So the size of the matrix is 5 cross 5. So we'll be given any input as plain text. So that input will be normally telling us keyword. Using that input we'll construct the matrix first, and then we go for encryption. So here we have some rules for constructing our matrix. So I told you the size of our matrix is 5 cross 5. First we have to fill the matrix with the letters in our keyword. And also the important thing is we shouldn't write the duplicate letters. We have to fill it from left to right, from top to bottom. First we will fill in with the letters in our keyword, that is input plain text, and now we'll have some remaining of the matrix. We will fill with the remaining alphabets, that is from A to Z. We have to check the letters which has been not in our keyword. We have to fill it with the remaining letters. And here the another important rule is the letters I and J, it is been treated as one letter. I will go for an example, and then it will be clear the procedure of constructing the 5 cross 5 matrix. And so here we have some rules for how we have to encrypt the digrams. So we'll see an example for constructing, and the plain text taken as keyword. Okay, so the first thing is if we have some duplicates, we have to go for adding a filler letter. That is the first rule for encryption. So we can see an example here, balloon. So here we are having two duplicates, LLOO. First we will divide it as digrams. So the diagram pair will be BA, LLOO and N. So first we will take the pair LL. As we are having the same repeating plain text, we have to fill it with the filler letter X. So here this will be treated as LX, LO and ON. So this is the first rule, and the next rule is if we have the plain text letters which will fall in the same row of the matrix, we have to replace with the letter to the right that is in the same row. If we have the nth letter, we have to go for circular shift from the last. So this is a rule for if the letter fall in the same column, we have to replace with the letter from top to bottom, and similarly as in the row wise we have to go for the circular shift from the last. And this is the last step of if we have the plain text letter, if the pair is in different row or different column, we have to take it as a diagonal, and then we have to replace with the end letter which falls in the diagonal matrix either in the same row or in the same column. So we can go for seeing an example. So I told you the plain text taken here is keyword. So first we will fill the 5 cross 5 matrix with the letter keyword K, E, Y, W, O, R and D. So now I have filled all the letters in my plain text, and now the remaining of this matrix must be filled with the alphabets which are not in this keyword. So I have to check from alphabet A to Z. So first I'll go for the letter A. So A, it is not in my input plain text. So I'll place it here, A. Okay, and now the next alphabet from A to Z is B. So B is not in our input plain text, so we'll fill it with B. And similarly, C is not in our input plain text, we'll fill it with C. And now D, it is already in our input plain text, so we need not go for D. So we can go for the next alphabet. So A, B, C, D, E. E is also there in our matrix, so we need not fill it with E. And the next F, it is not there in our matrix, so we will fill it with F. And G is not in our input letter keyword, so we'll fill it with G. Similarly for H. And now I and J, we have seen a rule already. I and J, it has been treated as 1. So we have to write I and J in one matrix. And now L, N, O is already there in our input. P, Q, R is there in our matrix. S, T, U, V, W is in our matrix. Y is there, and X and Z. Okay, so this is how we have to construct our 5x5 matrix. And now going for encryption, first we'll see row wise encryption. So you can see here EY. So E and Y has fallen in the same row. So this E will be encrypted as Y and Y will be encrypted as W. So E will be encrypted as Y and Y will be encrypted as W. Suppose we are going to encrypt WO, so our diagram pair is WO. W will be encrypted as O and O will be encrypted as K. Okay, so this is regarding the row wise encryption. Now going for the column wise encryption. So we'll take an example. So we'll take the pair DG. So this D and G falls in the same column. So D will be encrypted as G and G will be encrypted as N. Okay, so D is encrypted as G and G is encrypted as N. So we'll see another example. We'll take as NU. If our pair is NU, N is encrypted as U and U will be encrypted as E. Okay, so the elements, if we go for circular shift and we find the element in the last row of our column. So now we take the next pair E and P. So E is in some other row and P is in some other row. Similarly, it is in another column and P is in another column. So we'll form a matrix here, and now we have to go for finding the end element of this pair. So E, the end element in this diagonal matrix is Y. So E is encrypted as Y and the end element of P, the end element is N. So EP is encrypted as Y and N. Okay, so this is how we are going to do the encryption in this Playfair cipher technique. Hope this video it will be clear how we are going to construct this Playfair matrix as well as how we can go for encrypting. Thank you.